So hi everyone, welcome to Best Science Brain YouTube channel. Best Science Brain YouTube channel. Today we're going to take a look again at rectangular glass block prism, the experiment on refraction. So we have a question here, and this is model 3, part of the experiment on refraction. And we're trying to assess different ways by which questions can be asked using the rectangular glass block. In all this model, the procedure remains the same. The only difference is what you're asked to measure. So as a student, you can get the glass block from a scientific store. You buy it, you buy optical pins, you buy tracing paper or drawing paper or A3 paper. Then you buy thumb pins and then mathematical set. Then you get a PVC board or a softwood drawing board to do the experiment. So let's go to the question. It says, using the diagram above as a guide, carry out the following instructions. Number 1, fix a plain sheet of paper on the drawing board. Number 2, place rectangular glass prism on the paper and trace the outline A, B, C, D. Remove the prism. Number 3, draw a normal NMP to meet AB and DC at M and P respectively, such that AM and equal to DP equal to 2.0 cm. So let's go to the glass block. The outline is A, B, C, D. That's the outline. After that, we'll now find AM and DP. AM is 2 cm. So the point M is 2 cm from A. The point P is also 2 cm from D. They are equal distances. So at this point M, we'll draw a straight line. That's the normal. And the normal is NMP. Okay. We'll now go to the next IV. Say, trace the ray PO with 2 pins, P1 and P2, at P and O respectively, such that the angle MPO, that angle of incidence, is equal to 5 degrees. So let's go to the diagram and explain it. Now we're going to mark an angle of incidence at this point P. Look at the I, which is 5 degrees. And this angle we're talking about here is angle MPO. Angle MPO. That angle of incidence here should be 5 degrees. Okay. Then we'll go to V. Replace the prism on its outline. Trace the emergent ray with 2 other pins, P3 and P4, so that the line in a straight line with P2 and the image of P1 viewed through the glass prism. So we'll now go to the diagram. So we'll now place a pin at point P. Place another pin at point O and replace the prism. We'll now view the images from this side. From this side AB. You search the image from this side AB to locate P3 and P4. So, and the image, the point you're going to place P3 will be such that both the pin you place here and the pin you place at P will be in a straight line. You locate P3 and P4. Okay? Then we're going to join P3 and P4 with a straight line to hit the prism hit the face AB at the point O. I will also draw another normal here and that straight line here at the point O. Okay, let's continue. It said, measure and record file the angle between the emergent ray and the face AB of the glass prism. So where the angle? The angle phi, the angle between the emergent ray and the face AB, you have to measure it. You see that? Okay. VI, so evaluate cos phi and sin I. Then VI, I repeat the procedure for 4 other values of I, 10 degree, 15, 20, 25. Tabulate readings. Then S, plot a graph of cos phi on the vertical axis and sin I on the horizontal axis. Then SI, determine the slope of the graph. SII, state two precautions taken to ensure accurate results. BI, state the laws of refraction of light. Then II, explain what is meant by the statement the difference index of a material is 1.65. So let's begin the experiment. So we have to locate a point M on the face AB. From the equation, they say we'll measure AM to be 2 cm and also measure DP to be 2 cm. So you take a ruler, the cm end of the ruler, and locate 2 cm from the point A. We'll mark here. So this place is our M. We'll also locate 2 cm from the point D. We'll mark this point. This point is our point P. We'll do it for the second trace. 2 cm from the point A. Locate 2 cm from the point A. We'll call here M. 2 cm from the point D. We'll call here P. Then also the same for the next trace. We'll have 2 cm from the point A. At the point M. 2 cm from the point D. That is it. That is this point. We'll call here P. Then we'll draw the normal, meaning the straight line, from this point M to P, as given the instruction. We'll draw a normal, a straight line, passing through point M and P. That is it. So here is your 2 cm. Here is also 2 cm. So that is it. Do the same thing for the second one. You draw a normal, a straight line, passing through the 2 points, M and P. So 2 centimeter, 2 centimeter. Then go to the third one. Draw also a normal, a straight line, passing through the point P and M. So you have to be very accurate on it. So think of there's a shift here. Let's correct it. So here is 2 cm. Here is also 2 cm. So from the instruction, we're asked to measure the angle of incidence at P, as the first angle given to us is 5 degrees. The angle of incidence here is 5 degrees. So we get our protractor. To measure 5 degrees, what do? We put the baseline of the protractor, cover the line DC, and let the 90-degree line on the protractor cover the normal. So you can see the normal is covered by 90 degrees, and the baseline DC is covered by the baseline of the protractor. So this is 5 degrees. 5 degrees is here after 90. So this is 5. The other one is 10 degrees. So according to instruction, the incident angle here is 10 degrees. Apply the same statute the same way. The baseline covered by DC, and then the 90-degree here. You have the thick line covered 90 degrees. So this 10, 90 to 100 is 10. 100 minus 90 is 10 degrees. So you mark it here. Then the other experiment, the third one, we're using angle of incidence of 15 degrees. The baseline of the protractor covered DC, while the thick line 90 covered the normal 15 degrees. 90 minus 100 is 10. Then the next middle is now 15 degrees. So having done that, we'll now draw the incident ray. What's the tiny one? Be very careful, don't make mistake. You draw the incidence ray for the first one, the 5 degree. So you draw a line out. So this is I as 5 degree. For the second one, you also draw the incident ray passing through the point you mark for 10 degree. So you have it. You draw the incident ray coming out. So here I is 10 degrees. Then for the third one, you draw the incident ray passing through 15 degrees. So the place you mark for 15, you draw it out. So here I is 15 degrees. So To start the experiment, we have to place our optical pins. We are told in the question that we should place 2 pins at P and also another one at O. And this point is O. So we're going to place 2 pins. So we're going to place one here at P and place another one at O. Here. Make sure it's on the line. So you keep them straight. Then return your prism. The prism is returned. You see that? So we'll now view the images. Look at this diagram. The image is viewed from the face AB. So we're going to view the image from this side to find the emerging beam, not from DC, but rather from AB. So how do I view it? We're going to turn the board to view the image. So the board has been turned. So we are going to view the emergence ray from the face AB. As you can see, the letter there, A and B. So make sure that the search pin covers the 2 pins, this one and the one inside the mirror, inside the prism, please. So we'll have a search pin here. Okay. This one search pin to cover everything or block everything. It's one search pin. Okay, that is it. So having done that, we'll now remove. We'll now remove the prism. Remove this pin at P. Remove the one at O. Then remove the search pins. One is P3 and one is P4. So draw a ray from the search pin to create the emergent ray. So we'll have that. This is our P3, and this is P4. So that is it. So from the diagram, we're going to measure angle phi, the angle between the emergent ray and the face AB. The angle between the emergent is phi, between the emergent ray and the face AB. That's the angle that is here. We want to measure it. So we're looking for this angle here. The angle here is phi. To measure the angle between the emergent ray, and this is the angle between the emergent ray and the face AB. To measure this angle, how do I go about it? I'll put my protractor here. This is 90. Make this straight line the normal. The straight line, that the face of the prism, the normal. So the middle of the protractor will lie at the point O. So I put my protractor there. You can see it perfect. So the line of 90 is covering the line AB. You can see it very well. So when I have that, I read off this line, the line of the emergent beam. So if you look at it, here is 90. The angle here before, the angle here is 10. So 90 minus 10 is 80 degrees. They will now count 81, 82, and 83, and then 84. It's between 83 and 84. That's where the line is. So we can call it 83.5. So that means the angle here, phi, is 83.5 when the incident ray is 5 degrees. Okay. For angle of incidence of 10 degree, these are normal, which is, here is P, here is M, and here is N. So that's our normal, NMP. So we're going to place the optical pins at point P here, and also at point O. This is the point O. At point P and point O. So we'll have optical pins there. Replace the prism in between the 2 pins. You have your prism. Make it straight. And then we're going to view the emergent ray from the side AB. So we're going to turn the board and then view the emergent ray from the side AB. So we'll have to locate the emergent ray, the images with the search pin, blocking them entirely. Then another search pin blocking the first search pin. So that is it. So having done that, we can now remove the prism and then remove the pins. This point is our P3. These are P4. We then join P3 to P4 with a straight line. So you see that. With a straight line without making mistake. So now find the angle here. This is angle phi because this is our emergent ray. So we'll look for the angle here. How do we measure the angle? We'll get a protractor and make this line AB our normal, keeping the middle of the protractor at this point O. So this point O. So you have it there. Then you measure the angle, this line. We're looking at this line. So this line from here 90 to 20 is 70. So the angle here is, you read it very well, 71, 72 degrees. So angle phi for this angle of emergence is now 72 degrees for incident angle of 10 degrees. So this, we are now on to the angle of incident of 15 degrees. So we'll put our pin at point P and also put a second pin at point O. This is our normal. Here is N. Here is N. MP, the normal. So the pins be at angle at a point P and point O, being at P1 and P2 pins. So we return the prism. Turn the prism. Let it pass between the two pins. And then when you have done that, make sure you straighten the pins. Then make sure the prism cover the outline very well. We're now going to view the emergent ray from the side AB. That means you're going to turn the board to view it from the side AB. So with the search pin to view the images. So blocking the pins, both the one here and the one inside the glass block. Put the first pin. The second pin will now block the first search pin entirely, blocking everything. So that is it. So having done that, we'll now remove the pins. We'll remove the pins. We'll have this removed, this and that removed. We'll now draw the emergent ray to hit the point O. Have the emergent ray. This is the point O. So that is it. So here is our P3. Here is our P4. We'll now measure angle phi, the angle between the emergent ray and the face AB. As we explained, so we'll keep the middle of the midpoint of the protractor 90 degree on the point O, and make sure the line of 90 lies on the face of the prism. So we'll have it here. Very accurate. You see it clearly. The line of 90, the midpoint lies at O, and then the 90 lies on this line. We'll take this line as our normal. They will now rid of this line. This line coming out here. This line is for that angle. So the emergent ray. So This is 90 minus 20 is 70. This is 71.5 in the middle. So the angle here is 71.5 degrees. So we're now going to the angle of incidence of 20 degrees. So we have the arc line already drawn, A, B, C, D. We measured at our M and P, 2 cm from end A and 2 cm. M is 2 cm from end A and P is 2 cm from the end D. So we're going to measure the angle. The next angle we're going to is angle 20 degree. So angle 20 degree, we move our protractor. The baseline of the protractor will cover the line DC, while the 90 degree line will cover the normal. You can see that very clearly. So no mistake about it. So 90 degree here, this is 70. 90 minus 70 is 20. So the incident here is 20. Mark it as 70 because 90 minus 70 is 20 degrees. So having done that, we'll now draw our angle of incidence. Here, get it clear? And with a straight line, the incident ray, with a straight line to make an angle of incidence of I is 20 degrees for this experiment. Then having done that, we're now going to put our pin. The first pin, which is at P1, is at P. The second pin, which is at P2, is at this point, and this point is our O. On the diagram, the point here is O. So we're going to turn the board and then find the emergent ray from the face AB. So we're going to turn the board. So we replace by the prism. The board has been turned. We return by the prism here. So we are now, make sure you cover the outline very well and make the pins to be straight, erect. So this face is now AB. We'll now view the emergent, we'll trace the emergent ray. We'll view the images. So keep it straight and locate the image. Okay. Block that pin and then put under search pin to block the first pin. Okay, that is all right. Having done that, remove these pins. These are P3 and these are P4. Then use a straight line to join P3 and P4. Move them to the face of the prism to start from O. So that is it. Having done that, the emergent ray is leaving. So this one is going out as well. So we'll now measure the angle here, angle phi. To measure it, we make our OB, this line, take it as our normal. We place the 90 degree there with the midpoint of the protractor at the point O. Read off the incident ray. So this point is 90. The angle here is 30. 90 minus 30 is 60. We're reading off this line, the emergent ray, and is at 65. So our phi is 65 degree for angle of incidence of 20 degrees. We're now going to the incident angle of 25 degrees. For this, we draw the outline and then mark out 2 cm for M and 2 cm for P. So as illustrated before. So we're going to create angle of incidence of 25 degree. We place a protractor at the point P. So the baseline of the protractor covers the line DC, and then the 90 degree line covers the normal. 25 degrees, 70, 90 minus 70 is 20, then the middle line becomes 25 degrees. degrees. So having done that, we'll draw our incident ray so that we can create an angle of 25 degrees, incident angle of 25 degrees. So having done that, we'll have it very accurate, so no mistake about it. So you have 25, we didn't get it accurately. So clean off the line and then repeat it. So I have 25 degrees here. So that is right. Having done that, this is, we now put our pin. One of the pins, that is our P1 at the point P. We now put our P2 at the point, this point is the point O in the diagram. So this is the point O. We now return the block, glass block in between them. We then view the emergent ray from this side, AB. So we're going to turn the board and then view it through the side AB. So we'll now view the emergent ray, we'll view the images from the face AB so that we can locate the pins on a straight line. I have one there and have another one there. So having done that, remove the pins, then use a straight line, diameter rule, and join these points. They're very close, so you can read off the angle. So having done that, I get my protractor. I read the angle here. That's angle phi for 25 degree incidence angle. So you use your, this is your O, remember your OB as your normal. So you keep your O, your line, your 90 degree on this line with a midpoint at O. Then read off the incident angle. There is this line, which is the incidence ray. So this is 90 minus 30. That is 60. After 60, you have 61, 62, 63 degrees. So here, our phi is 63 degrees. So let us collect our results. So we'll now move to record our readings. For the first experiment, the incident angle is 5 degrees. We have on the record book 5.000 to 4 significant figures, 5.000. Then phi, which is the angle of emergence measured, is 83 degrees. 83 degrees, okay, we have 83.5 degrees, that's the right value, 83.5 degree. So our phi here is 83.50 degrees to 4 SF. Then we find cos phi. So our cos phi, cos of 83.5 degrees, going to be, let's find it, cos 83.5 is 0.1132. That is cos phi. We have to find sine I. Sine 5 degree. Sine 5 is 0.08716. All values to 4 SF. Second experiment. Our incident angle is 10 degree, recorded here. Our angle of emergence phi is 72 degrees. So write 72.00 to 4 SF. We'll now find cos of the angle of emergence, that is phi, cos 72 degrees. You're giving us cos 72 degrees is 0.3090. We also find sine I, that is sine 10. sine of 10 degrees is 0.1736. So we go to the third angle of incidence, which is 15 degrees. Our phi or emergent angle is 71.5 degrees. Record here 71.50 under phi or our angle emergence. Then cos phi, that is cos of 71.5 is 0.3173. And then sine 15, that is sine I. Sine 15 is 0.2588. We now go to the fourth and the fifth angles. The fourth angle incidence is 20 degrees, which is this experiment. And then the angle of emergence measured is 65 degrees. So we have phi at 65.00. We have to find cos of that angle of emergence, that is phi. So cos 65 is 0.4226. We also have to find sine of angle of incidence, sine I. Sine of angle of incidence, that is sine 20, is 0.3420. Then the fifth experiment, which is angle of is 25 degrees. We measure the angle of emergence, that is phi, at 63 degrees. So now right here, 63.00. We have to find cos phi, cos of 63 degrees. So cos 63 is 0.4540. And then we're going to find sine of incidence, sine 25. Sine 25 is 0.4426. So for observation, we saw that as the angle of incidence increases, the angle of emergence, which is phi, decreases. So we can see that the cos of the angle increases. Likewise, the sine of the angle also, the cos of angle of emergence increases, while the sine of the angle of incidence also increases. So we're now going to go to our graph and plot a graph of cos phi, cos of emergent angle on the vertical axis against sine I, sine of angle of incidence on the horizontal axis. We're about to plot a graph of the experiment. We're plotting cos phi, and that phi is the emergent angle against sine I. So cos phi on the y-axis or on the ordinate, and then sine I on the horizontal axis, s-axis, or known as the abscissor. Look at the values of cos phi: 0.1132, 0.3090, 0.3173, 0.4226, 0.4540. And then the corresponding sine I: 0.08716, 0.1736, 0.2588, 0.3420, 0.4226. The values are similar because we look at the values; they are all one. We have only one 0 point. That is what I call it. They are all 4 decimal places. So we're going to choose a scale to cover the two axes. I'm going to choose a scale of 0.124 cm to 0.1 unit on both axes. So let's start on this. This is the cos phi axis. This place is 0. One boss is 2 cm. 2 bosses will be 4 cm. So 0.1 for 2 bosses. So count under 2 bosses, 0.2. Under 2 bosses, 0.3. Under 2, 0.4. Under 2, 0.5. So you look at the cos phi. The highest value on cos phi is 0.45454. So that's why we extended the scale to 0.5. Then we'll now go to sine I as the same scale. We'll have 2 bosses of 4 cm to 0.1 unit. So 0.1 here. After 2 bosses, under 2 bosses, 0.2. Under 2 bosses, 0.3. Under 2 bosses, 0.4. So this is sine I. So let's check the higher value on sine I. As the higher value on sine I is 0.4226. I will have 0.4 here. This one going to be 0.45. So we have the right scale for this graph. So we'll now write the scale. We'll say 4 cm to 0.1 unit on both axes. 4 cm to 0.1 unit on both axes. Then, since we have done that, we're going to find what one line represents. Remember that there are 10 lines in a bus, and there are 2 buses here. That means 2 buses will have 20 lines. So one line will now become 0.1. One line will be 0.1, the smallest unit or scale, all over 20. And that gives us 0.05. So 0.005. So one tiny line will give us 0.005 unit. So that means 2 lines, to be faster, will become 0.005 times 2, giving us 0.10. So we want to count our scale faster. 2 lines will give us 0.10 unit. So let's go to the plotting. The value will plot to 2 decimal places. So cos phi is 0.11. Y sine I is 0.087. So we'll go to the vertical axis and locate 0.11. So this is 0.1. As you say, 2 lines is 0.1. So this is 0.1. Then the 2 lines after 0.1 give us under 0.01. So that gives us this is going to be 0.11. So 0.01. So this is this should be 0.01, not 0.1. 2 lines 0.01. So since one line is 0.005, so 2 lines give us 0.01. So coming to this point again, this is 0.1. If you add 0.01, that gives you 0.11 for what we are looking for, which is 0.11 here. Then sine incidence of an angle is sine I is 0.087. We can take 0.0 because not be easy to read 87. We can take 0.09. So we'll go to the horizontal axis and look for 0.09. We know that one line is 2 lines is 0.01. So then this is 0.1. The middle is 0.05. Since this is 0.1, so 0.05. Next 2 lines 0.06. Next 2 lines 0.07. Next 2 lines 0.08. And then next 2 lines 0.09, which should be here. So we'll take a ruler and then find the point of coincidence between the 2. We'll move up, and that should be here, will be 1, and then 2. That should be at this point. This is the point of where the 2 points merge. We'll put our asterisk or our dot there. So having done that, we'll now go to the next point, 0.31 on the vertical axis. We'll locate it. This is 0.3. I will know that 2 lines is 0.01. So this is 0.3. Next 2 lines will give us 0.01. That give you, adding 0.01 to 0.3, you now have 0.31 here. And then on the vertical horizontal axis, we want to locate 0.17 for sine I. So this is 0.1. This is 0.2. Middle is 0.15. So move up. This is 0.15. We'll move up second line. So that is here, 0.15. Then next 2 lines, 0.16. Next 2 lines again, 0.17. So this is the point of coincidence, or where the 2 points come together. So where they merge. So we'll have that point there. Then we'll have a 0.32 for cos phi, 0.32 located here. So this already is 0.31. Add another 2 lines, that becomes 0.32. And it merges with 0.26 for sine I. So we know that this is 0.2, this is 0.3. The midpoint is 0.25. Put a ruler there and trace it up. So now move 1, 2, 3, 4. This is where we have 0.3, where we have 0.32 on the vertical axis, 0.32, and we're going to count 0.26, but it is 0.25. So 2 lines forward will give you 0.26, which should be here at this point. So having done that, we go to the fourth plot, 0.42 for cos phi, 0.42 for cos phi. So go to look at 0.42, this is 0.4, and then 2 lines is 0.01, 0.4, the next 2 lines is 0.41, the next other 2 lines is 0.42, so the fourth line. Then it coincides with 0.34. We apply it to 2 decimal places. So this is 0.3, that line of 0.3. We move up to 4 lines, 1, 2, 3, 4. This is 0.3, and then this is 0.42 on this side. So from 0.3, we count 0.434. So 2 lines forward is give us 3.1, and that 2 lines give us 3.2, and that 2 lines give us 3.3, and that 2 lines give us 3.4, which should be here. So having done that, we'll now go to the last point, 0.45 for cos phi, coincides with 0.42 for sin I. 0.45, we locate 0.45 on the vertical axis. So 45 is the midpoint, because this is 0.4, this is 0.5. And then 0.42. So this is 0.4 here. We'll put a ruler here at 0.4. We'll move up and locate 0.45. We're looking for 4.2. I know that this is 4.5 here. 4.2 is 0.4 here. I know that 2 lines will give you 0.01. So this is 0.4, 0.41. 2 lines, and that 2 lines will be 0.42. So that is here. So having done that, we can join the points together. You see, we're having a kind of a best line. So we have look for the points that will give us the maximum, the number of points that will be the maximum number of points that be in a straight line. So we're having about 3 points in a straight line. So you can see that clearly. So we join that. About 3 points on the straight line. So that is it. That shows a good experiment. So where 2 points are off from the straight line. So study the maximum points. So the next is to find the slope. To find the slope, we can take a wide range from the first point here, and then we'll now take this point here. So we'll do for the coordinate. The coordinate, if you move it to the vertical axis, here is 0.42 approximately that was plotted. Then here on the coordinate on the lower coordinate on the vertical axis is 0. Here is 1. Let's get it right. 0.42 for that one. Then this is 0.11 for this other end. Then going to the horizontal axis, the coordinate on the sin I axis here is 0. Let's get it right. 0.34. If you go down, then for the other one, the coordinate on the horizontal axis is 0.09. So take our slope here and the change on cos phi axis over the change on sin I axis. Find our slope. We now have change on cos phi axis all over change on sin I axis. So the difference for the cos phi axis, the coordinates are 0.42 minus Here we're having 0.11. All over. On the other one, we have 0.34. The result is minus 0.09. So this is 1, 1. And this is 4, 2. And then minus 0.11, 0.34 minus 0.09. So when we solve this, we get approximately 1.24 as our slope for this experiment. 1.24 as our slope for this experiment. Question SII says, state 2 precautions taken to ensure accurate results. Precautions are: 1, I ensured that I avoided error due to parallels in locating the object pins using the search pins. Number 2, I ensured that I avoided error due to parallels in reading the meter rule and the protractor. So these are necessary precautions. Number B, I says, state the laws of refraction of light. State the laws of refraction of light. There are 2 statements that make up the laws of refraction. The first statement says the incident ray, the refracted ray, the incident ray, the refracted, not reflected, the refracted ray, and the normal at the point of incidence all lie in the same plane. Second statement is the Snell's law, which states that the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. So these 2 statements are the laws of refraction. Number BII says, explain what is meant by the statement, the Fine index of a material is 1.65. Explain what is meant by the statement, the refractive index of material is 1.65. It means that the ratio of the sine of angle of incidence on the material to the sine of angle of refraction in the material is 1.65. Or you say the ratio of the velocity of light in air to the velocity of light in the material is 1.65. Or you can as well say the ratio of the wavelength of light in air to the wavelength of light in the material is 1.65. So we have come to the end of this model 3 experiment. Stay connected. Don't forget to subscribe and tap on the button if you are not subscribed. Then we're going to present to you the model 4 in the soonest time.